Hello, welcome to my second in a series of videos for L'Hopital's rule. It's for Calculus BC, section 8.2. And you can see in this particular case we have the limit as x approaches 0 of sine x over x. And that's one we're actually supposed to have memorized, but if you find that you've forgotten it, then just use L'Hopital's rule. We'll check to make sure that L'Hopital's rule actually applies. For L'Hopital's rule to apply, it has to be an indeterminate form, as described in the previous video. So if we try taking the limit, sine of 0 is equal to 0. So we can say that this is approaching 0, and of course as x approaches 0, x is 0. So it's 0 over 0. It is indeed an indeterminate form. So we can take the derivative of the numerator and the derivative of the denominator and then take the limit of that. So we'll bring down the limit notation. Limit as x approaches 0 of derivative of sine of x is cosine of x. And the derivative of x is 1. And so now we can take the limit of this. And so that limit, cosine of 0, is of course 1. And as x approaches 0, 1 is still 1. So you see that this is equal to 1. And that's our answer for this problem. So the limit as x approaches 0, sine x over x, is equal to 1. All right, now we can go on to the second problem. And the second problem, we're taking the limit as t approaches 1 of 5t to the fourth minus 4t to the fourth minus 1 over 10 minus t minus 9t cubed. And so first, let's just try doing like we always do when taking the limit, and just try plugging in the value that t is approaching. So we start plugging that in. We'll get 5 minus 4 minus 1 over 10 minus 1 minus 9. And you see the numerator is approaching 0 and the denominator is approaching 0. So again, it's that indeterminate form of 0 over 0. So we can take the derivative of the top and the derivative of the bottom using L'Hopital's rule. I actually like to use in notation here saying use L'Hopital's rule, and I just abbreviate it LH. So use L'Hopital's rule, find out the limit as t approaches 1 of 20t cubed, right, that's the derivative of 5t to the fourth, minus 8t minus 1 over, oops, that's a 0. So derivative of negative t is negative 1, and derivative of negative 9t cubed is negative 27t squared. And you can see the mistake I made here in the denominator. I also made the same mistake in the numerator, so let's fix that. So now we can try plugging in as t approaches 1. We get 20 minus 8 over negative 1 minus 27. So that's 12 over negative 28. I believe 3 goes into both of those, and that would end up being negative 4/7. And that's our answer to this particular limit problem. And again, using L'Hopital's rule, make sure that you're finding out that it's an indeterminate form before you start plugging in, or before you start taking the derivative of the top and the bottom. Use the notation saying you're using L'Hopital's rule so that the person reading the problem can see what you're doing. And it's pretty straightforward for these. All right, let's move on to the third example, the last example of this video. And I'm not sure why that's showing up on top of there. We'll see if we can turn that off. All right, so now example 2c, we're taking the limit as x approaches infinity of e to the x over x squared. So you can see this is a different one because t is approaching, x is approaching infinity. So this is in behavior instead. So e to the infinity, of course, would be approaching infinity, and infinity squared would also be approaching infinity. So this is the indeterminate form of infinity over infinity. So again, L'Hopital's rule applies. Use L'Hopital's rule. Again, tell me that you're doing that. And this becomes the limit as x approaches infinity of the derivative of e to the x is e to the x, and the derivative of x squared is 2x. All right, and we try taking the limit by plugging in infinity here. Again, we're getting infinity over infinity. So it's yet another indeterminate form. Well, if L'Hopital's rule works on this one, and this limit is equal to this limit, then we can just use L'Hopital's rule for this one again, and you can see that you could be required to use L'Hopital's rule lots of times. Let's see how many times this one takes. And we get e to the x on the top again. Derivative of the bottom is 2. Now this is no longer an indeterminate form. We get infinity over 2, and of course that is approaching infinity. All right, so that's our answer here. Now there's another way of looking at this. If you just think of the end behavior of both of these functions, e to the x is a much more powerful function. It grows much faster as x approaches infinity than x squared does. So obviously the numerator is going to win the race towards infinity. So you could see right away that this is equal to infinity. But if you need to show the work using L'Hopital's rule, this is how you can do it. All right, well thank you, and please look for my next video for L'Hopital's rule. There will probably be 2 more. Thank you so much for listening.